Hi again. Let's do some simple calculation of pulmonary and alveolar ventilation rates. This is not complicated math. It's pretty straightforward. It's 2 slides, but I would like you to be able to do these simple calculations. So, first slide, calculating pulmonary and alveolar ventilation rates. And this will be in mils per minute. And what we're looking at is the total volume of air going into the lungs, which is the pulmonary, and then what part of that air going into the lungs actually makes it into the alveoli. So tidal breathing, we've talked about that before. It's about 500 mils in and out. That's the total volume when measured from the mouth into the lungs and back out. Now that 500 mils, not all of that 500 mils gets into the alveoli, some of it stays in the trachea. So that's referred to as the dead space, the non-respiratory spaces. So if 350 mils of that 500 actually gets into the lungs to the alveoli, that is then the alveolar ventilation. So with each tidal breath, in this example, you inhale 500 mils, 350 of that is what actually gets into the alveoli. So the pulmonary ventilation rate, simply the tidal volume, how much air do you breathe in through the mouth per breath? Well, if it's 500 mils per breath and there are 12 breaths per minute, then it basically is just 12 times 500, and that is our pulmonary ventilation rate. When you set up the problem and you do it correctly, you'll notice that breaths cancel out. Pretty straightforward, not a lot to it. Alveolar ventilation is the same idea, but you subtract out the dead space. So again, if we start with a tidal volume of 500 mils with each breath, and we have the same respiration rate, 12 breaths per minute, and the dead space is 150 mils, that's the 150 mils that doesn't make it into the alveoli. So you subtract that out. So you have 500 minus the 150 gives you 350 times 12 be 4,200 mils per minute. So alveolar ventilation is going to be less than pulmonary ventilation. So practice with some of the numbers, practice setting up the problem to where you can cancel out the units correctly. The next slide is a graphic of this idea. So we'll just work through it by the numbers, starting with number 1. And this is at the end of inspiration. So this is representing the volume in lungs at the end of inspiration. Those are all the alveoli. That's the balloon, if you will, of the lungs. And it's 2,700 mils. We inhaled, and here is the 150 mils that is in the dead space. Okay, and then we go to exhale. We exhale the 500 mils. Here is the 500 mils. 150 of that was in the bronchioles, the trachea, the oral cavity, and 350 came out of the alveoli. So we exhale that. The volume went from 27 to 22, so we lost 500 mils, and that's what we exhaled. And then at the end of exhalation, step number 3, we're sitting here with this 2,200 mils, and 150 mils is in the dead space that came out of the lungs. So it's sitting there, it's sort of stale air. Then we go to inhaling another 500 mils of fresh air. We're over here at step 4. In comes a new 500, all fresh. And 150 of that is left in the anatomical dead space, the bronchioles, the trachea, etc. 350 goes into the alveoli, and it pushed that old stale air, the old 150, back into the lungs again. So even though we inhaled 500 mils, we only ventilated the alveoli with 350. And then we go back to where we started. So you should be able to work your way through this and make sense out of the 500 mils that are being exhaled and inhaled. Okay, that's it for that. And next unit, we'll talk about Dalton's Law. See you soon.